Welcome to the Silicon Learners. Today's topic is non-blocking and blocking assignment. So, what is non-blocking and blocking assignment? We will learn in today's topic. Okay. So, we are demonstrate like this. This is a sign of blocking assignment. And this is a sign of non-blocking assignment. Okay, so this is basic idea of blocking and non-blocking. Now if you think blocking and non-blocking are just two ways to assign values, your simulation is already misleading you. Same code, different behavior, right? And most beginners don't even notice. So code difference is blocking means execution is line by line, and non-blocking means execution is schedules. Non-blocking schedules the update, not instant. So core difference is blocking is schedules, non-blocking is schedules the update. Okay, so core difference is blocking execute instantly, and non-blocking execute schedules the update, not instantly execute. So we are move on code for better explanation. So here is our code. I use model sim simulator for the explain this code. This is our module test, where inputs are clock in 1, into n in 3, output are range 1, range 2 and range 3. Here is our logic. Always set that positive edge of clock, means every positive edge of clock we are assigned range 1 as a delay 20 in 1, means after delay 20 our range 1 is assigned as in 1. At range 2 we assign as a negative edge of clock into XOR in 3. This expression perform at negative edge of clock, and then range 3 equals to range 1, simply assign it. Okay, now this is a code of blocking assignment. You can see this is a blocking assignment. Okay, now we look at a simulation behavior, then control S and simply compile code. Here is our simulation for it. Okay, we just open it, and this all ports objects add to our wave. Here we will assign clock first. This is a clock signal, so assign clock first. We will assign clock here. We will force in 1 as a 1. We will force in 2 as a 0. Wait a minute. We will force in 2 as a 0, and we will force in 3 as a 1. And now we will run our code. Okay, 1 second, run. Okay, now look at the output, range 1, range 2 and range 3. So according to our code, at the red positive edge of clock, range 1 equals to delay 20 in 1. So I explain in the waveform. At this here, at the positive edge of clock at 100 picosecond, after delay 20, means at the 120 picosecond, our range 1 should be in 1. We assign in 1 as a 1, so range 1 is 1. Next we will see in the code we describe range 2 equals 2 at the negative edge of clock into XOR in 3. If we assign in 2 as 0 and in 3 as a 1, means 0 XOR 1 should be 1. So we see at negative edge of clock range 2 is 1, means into XOR in 3, into is 0, in 3 is 1, 0 XOR 1 is 1. And our last expression is range 3 equals to range 1, means reg 3 assigned as a reg 1, and we see this is performed instantly after this expression, this. Okay, so blocking assignment, we can say blocking assignment execute instantly. Okay, so this is a sequential execution inside same clock edge. This is all executed like in a C language execution sequentially, line by line at the rate same positive edge of clock. Now we will see another demo of non-blocking assignment. We simply make it non-blocking first. Close it and Control S and compile. Here is our simulation. We will add it in this way. Simply again we will provide first click clock, then in 1 as a 1, in 2 we will provide value 0, and in 3 we will provide value 1. Okay, and run these signals. Once again run and run. Okay, now we will look at our non-blocking code. According to this code, at the rate positive edge of clock, our reg 1 is assigned as in 1. Okay, so here is positive edge of clock at 100 picosecond, and after delay 20 means at the 120 picosecond our reg 1 equals to in 1, which is 1. Okay, we'll go at next expression. At negative edge of clock into XOR in 0 operation performs. Okay, so at this here negative edge of clock into 0 in 3 1 0 XOR 1 1 performs. Okay, and at the next reg 3 equals to reg 1 performs. Okay, so at this positive edge of clock reg 3 equals to reg 1 performs. Now look at back at a blocking assignment. This expression perform instantly. Reg 3 equals to reg 1 perform instantly, means after it here we get reg 3 equals to reg 1, but in non-blocking assignment we look at next clock edge. Okay, so this is the main difference between non-blocking and blocking, where blocking assignments execute sequentially at same clock edge, and non-blocking assignment executes at every clock edge. It is sequentially but every clock edge performs. Okay, now golden rules are: use blocking assignment for combinational logic, and use a non-blocking assignment for sequential logic. Okay, if you mismatch in blocking assignment and non-blocking assignment, your simulator won't warn you about this. Your code will run but your design still be wrong. That's why understanding behavior matters more than syntax. Okay, so this is about blocking and non-blocking assignment. We will meet in next video. We will see again new topic in the next video. Thank you.